my name is Viviane Pierrard and I lead the Solar Wind team at the Royal Belgian Institute for Space Aeronomy. For the project BIOSPHERE, I study the influence of the Sun and the galactic cosmic rays on the atmosphere of the Earth. In 2024, February especially, there were a lot of solar eruptions that were observed, as shown here by Solar Dynamics Observatory. More recently, on 22 February, a big coronal mass ejection was observed, as illustrated here by SOHO. Such solar eruptions are more and more numerous because the solar activity follows a cycle of 11 years and the next maximum is expected in 2025. When such a giant flux of ionized particles is emitted in the direction of the Earth, they arrive after typically 1 or 2 days, and they have very important consequences for the space environment. Fortunately, we are protected by the magnetic field of the Earth that deviates most of the particles to the high latitudes, giving nice auroras. The particles of the atmosphere are excited by the injections of the solar particles, so that they emit lights with different colors depending on their species, at altitudes typically between 100 and 200 kilometers. During such geomagnetic storms, the ionization of the atmosphere is also higher at high latitudes, what modifies the propagation of radio waves. The most important part of the atmospheric ionization is nevertheless due to the solar ultraviolet radiation during the day. It is higher close to the equator because this is where the sunlight is the most intense. The maximum of ionization is between 100 and 400 kilometers and forms the ionosphere. The atmosphere protects us from this solar ultraviolet radiation, and especially the ozone layer that filters the ultraviolet and X radiation, so that very few can reach the surface of the Earth. Another source of ionization is due to galactic cosmic rays, mainly very energetic protons and alpha particles coming from the galaxy. They are less intense but much more energetic than solar particles, and so they penetrate deeper in the atmosphere, as shown here for 9, 12 and 30 kilometers. The terrestrial magnetic field also protects us from the galactic cosmic rays. We study these injections of galactic cosmic rays, solar energetic particles and ultraviolet radiation in the framework of the project BIOSPHERE to determine the intensity and the evolution of these radiations, as they are dangerous for humans, animals and plants. If you are interested to know more about this topic, you can refer to my tutorial book corresponding to my university course published at the University Press of Louvain.